topic of Professor May's speech is Internet Well, a new paradigm for Internet-based software engineering. Let's welcome.
Good morning, ladies and gentlemen. It's my great pleasure to be here to give a talk to you. I would like to deliver my thanks to the conference for giving me this opportunity to introduce some research and practice on software engineering in China. Okay, my talk consists of 4 parts. In the first part, I will review the software paradigm and its shift in the history of computer science. And the second part, I will analyze the challenges and the demands for software in internet computing and introduce the new software paradigm for internet as a computer. We coined a word internet wheel to denote this new paradigm. In the essence, internet is a technical kind of software which needs broad software engineering. A brief introduction to the research on internet in China is given in this part. The third part will focus on the engineering of internet, and the first part will give some my personal thought for the future of the global software engineering. So, what's a paradigm? Based on the definition, a paradigm is a model for something which explains or shows how it can be produced, or it is a clear or technical example of something. So there are many paradigms for different areas. For example, scientific paradigm presents what is to be observed and scrutinized, and the kind of questions that are supposed to be asked and probed for answer in relation to this subject. And also the scientific paradigm also concerns with 3 how. How this question to be structured, how the results of scientific investigations should be interpreted, and how its experiment to be conducted, and what equipment is available to conduct this kind of experiments. For software in our computer science area, software paradigm or program paradigm refers to the software model and its construction theory from the perspective of a software engineer or programs. As shown in this picture, a software paradigm defines what is to be constructed and executed, how to construct or develop this kind of software artifacts or entity with high quality and productivity, how to support the equation of the software artifacts or entities, and how to measure the result of the software and its execution. Paradigm shifts means a great important change in the way something is done or thought about. In the history of computer science, there have been several paradigm shifts, including the structured paradigm, the object-oriented paradigm, the component-based paradigm, and currently the popular service-oriented paradigm. One observed fact is that when the software paradigm evolves, the revolutionary challenges and the tremendous opportunity becomes software technology as well, where the 4 parts, what to be, how to do, how to run, and how will change significantly. For example, from the structured paradigm to OO paradigm, a big change is from the procedure objection to data objection. We can use OO methodology to naturally describe the structure of the objective world with the abstraction and the encapsulation of objects or classes. their relationships such as inheritance, delegation, and so on. With this paradigm shift, many new programming language emerged to support the old paradigm development, like Smalltalk, C++, Java. At the same time, some new research direction emerged, such as object-oriented operating system, OODBMS, and many object-oriented tools for the software development. In 1990s, distributed object-oriented technology was paying more and more attention. Component-based paradigm was proposed to change the overall paradigm. For the component-based paradigm was supposed to enhance the object-oriented paradigm with self-description capability and network access, and to support the using existing software resources to build some new applications. And there emerged some distributed object models, such as Microsoft's COM and DCOM, OMG's COBA, OM and CCM, and Sun's Java Beans and EJB. The different middleware platform was provided to support the running of the component-based software system with container to support the execution of a component. Okay, so with the wide use of internet, SaaS, so the so-called software as a service becomes the new model for the software usage through the internet. Where service-oriented paradigm enable the interoperation among different applications over the internet. SOA and the web service become the hot research topic. However, with the development of internet, beyond its basic network connection and information publish and sharing functionality, the internet is evolving to be a global and ubiquitous computer. The internet not only consists of a huge and even growing number of the device computing devices, and also serves as a platform with much more powerful support for the problem solving. So one question was asked, what is the next paradigm for the emerging of internet as a computer? Now I will enter the second part. So to identify the new paradigm for the internet as a computer, we first introduce internet computing and its some characteristics. In the past decades, after the dot-com bubble, many new concepts and topics have been proposed for the constructing and optimizing the internet ecosystem, such as green computing, cloud computing, visual computing, service computing, social computing, semantic computing, and so on. In our opinion, these concepts terms are just different perspectives to view internet and different efforts to follow this big trend. That is, internet is becoming an open, global, ubiquitous, and smarter computer for our society and the planet. There is no doubt that the software is everywhere, and play very important roles in this perspective. If we view internet computing from the perspective of software technology, what should be software system and internet computer? What is the software or paradigm model? What are the suitable programming language and the engineering methods? What is this suitable operating system for internet as a computer? And how to use the application on the internet? Software internet computer shows some new characteristics. Well, technical characteristics are on-demand calculation. Now let's take an example. This picture shows example. This picture shows the actual N1 control and the telemetry model in China several years ago. In H1N1 control and provision, that it requires collaboration among a number of organizations and individual software systems and services, such as airlines, hotel, hospital, and the mobile phone service provider. This and cooperation should be on demand or embedded. That is, the cooperation may happen anytime and anywhere among anyone. And the cooperator may have no or little relation before and after. We need the technology to enable the dynamic interoperability of software components and services distributed over the internet. We can also show a negative case of on-demand cooperation. Suppose Angela and Andy are friends, and one day Angela is on her busy travel in hotel and calling home. Andy makes some telephone call forwarding service, which forward a call to his company, to his office when it is not at home. However, Andy's office phone is equipped with a service terminating call screen. So this service will terminate the incoming call when the caller's number is on the blacklist in the hotel. If the hotel number is on the blacklist, the forward call will be terminated. Here we can observe the regular service of features calling forwarding, and call forwarding and the terminated call screen are connected respectively, but their interaction may cause trouble. Hence, on-demand cooperation needs to perform at the right time, on right place, and the service and the server for the right people. The second example, also for the negative cooperation, is some multiple regions may compete for some HTTP resource, So today's popular software paradigm cannot enable the on-demand cooperation in a natural and cost-effective way. For example, both the structured program and object-oriented paradigm support the hardwired cooperation. The entity are procedural objects, where their interactions are fixed by predefined procedure calls or object method, the message method. It is a pre-compilation. The component-based paradigm supports those we call the connection, because of the component implementation can be changed with the connector affixed to the but the connector affixed to the component type. The service-oriented paradigm supports flexible cooperation and goal-driven cooperation, because the service provider and the interaction can be changed dynamically, but the service flow should be predefined. In fact, the on-demand cooperation can be observed in some theoretical and domain-specific paradigm, like the agent-oriented paradigm and end-user programming and machine. But the dominant or popular paradigm support it directly. Besides the collaborative and imagined future, Internet computer also have some other key features, including the autonomous situational evaluable and trustworthy. We call it future. This is the SECAP. So actually, the cooperative means the software can interact with others in static, dynamic, and even on-demand manners. And the imagined means the software may have some undesigned behavior and unexpected effects on its runtime instance of interaction with other components and the services. Autonomous means software is relatively independent of others. It can perform operation as it will and adapt itself when necessary. Another feature is situational. Situational means software is capable of perceiving its one-time environment and scenario. And also the available means software is easy to add, remove, and change its functionality on the fly and just in time. And also the trustworthy means software should permit some kind of trade-off among the processor quality, internal system quality, and the external system quality, and some usage quality and usage quality. So, in summary, for this intercomputer features, we believe this big challenge for fundamental and the new software paradigm are equal. And reflecting the pattern for evolving paradigm in the computing history. Since there were about the software running on the internet, we call it a new term, a new word, the so-called interware, to catch the exact meaning of the new software term for internet computing. Hence, interware could imply two folds of meaning. So, on one hand, interware is a software paradigm for internet computing, where the software is architectured as the internet, developed with the internet, executed on the internet, and provided as service via internet. On the other hand, sometimes we also use the interware to deliver such kind of software system itself. Generally speaking, the interware is constructed by a set of automatic software entities distributed over the internet, and a set of connectors enabling the collaboration among these entities in various manners. This slide shows the behavior model of interware from a micro perspective. That is, the software entity collaborated with each other on demand. Software entity can come and go automatically, and connecting from one protocol could switch to another dynamically. And this picture shows the organization model of the interware. The organization model is viewed from the macro perspective. The software entity can organize themselves into an application domain, which could also evolve dynamically. Accordingly, the engineering of interware is reused based. The development of interware can be seen as a composition of various disordered resources into ordered software systems. As the time elapses, changes of these resources and the environment may disorder the existing software system again, which will become audited by component sooner or later. The iterative transformation between the orderly or disorderly entity imply a bottom-up, inside-out, and a spiral development process. As the usable entity are distributed over the internet and composed over the internet, so interware system essentially is the growth of engineering. I will describe interware engineering methodology and the tools supporting the next section. So I would like to use this opportunity to introduce briefly some research on interware in China first. So the interviewer brings some new experience and values to all stakeholders of software. That is, the developers, operator, and the users. For the developer, they can program on physical and local library, and resource, as well as virtual and web delivered ones. Implement the software that could be virtualized and web delivered later. For the user, they can enjoy software anywhere, anytime, any device, enriched and consistent experience. For example, the Yap map running can run on IE browser. It is unaware of local resource, and it can run an Adobe Air aware of local resource such as the emails. And if this map runs the iPhone, it is aware of local resource and the user context such as GPS information, the temperature, and light. For the operator, they can perform collaborative management while leveraging the inherent management capability and visualization. And the management capability and the task are visualized and web delivered later. So with the scalability and the dependability. The time interval was proposed in 2000 year, and the interval research has been initially supported by the government in 2002 through the National Basic Research Program, which usually is so-called the 973 program. Now interval research has been supported by almost all the national R&D program, including National Science and Technology Major Project, National Key Technology R&D Program, the so-called the 862 program, and the National High-Tech R&D Program, National Basic Research Program, and the National Natural Science Foundation. This picture also shows the funding support system in China. So actually in China, we have two major funding sources directed by the government. So one is the NSFC. This is for some free research, National Science Foundation. And all of this is, this three is under the Ministry of Science and Technology. This is for some National Basic Research Program from some big project. And this one is 863. 863 is the National High Technology R&D Program, the high-tech program. So actually, this program was launched in 1986 March. This is 1977 March, and also have some key. We call the key project, key program. It's a National Key Technology R&D Program and the major program. There are some. This two funding support the fundamental research, and also some overlap between these two fundings for technology R&D, and this two is focused on social and for the social and the economical development in China. So this picture shows the organization of the interview research. So this project was supported by the License 3 program from the 2000 to 2008. That included 80 faculty, 70 postdocs, and 88 PhD students, and many master students. So this is the Tsinghua University Institute of Software of CAS, the East China Normal University, Nanjing University, and the Academy of Science of System Science of CAS, and other universities. So the Peking University is the PI of this program. And the second time is high confidence interview. So IBM joined as a first foreign company in license program. It's from the 2009 to 2013. There are more than 100 faculty are involved in this project. And this picture at the same time, in this almost the same area, so this project also gets support from 863 program, which is supported by this was some Beihang University, National University of Defense, Peking University, Institute of Software, Nanjing University, Fudan University, and also some software company are involved in this project. So this project is from 2007, the trustworthy software development tools and integrated environment. So from now this project is still ongoing. The trustworthy development one-time evaluate technology and the service support even for large-scale interview. This is a high-tech program. This is the funding, the two main funding resources for interview research in China. I would like to use this picture to show some output of our research. So after more than 10 years research and practice, we established an architecture-centric technical framework for interview. So the research focuses on agent-like entity, on-demand computation or cooperation, bottom-up knowledge-driven engineering, self-organization, domain community, and middleware support. We have an interview software model, interview middleware platform framework, and the interview engineering approach, and the interview tools and IDE, and some them are case study and our application. Due to the time limit, that we could not tell more details about our research. For more information, you can check some articles such as, so this is an article published on HB Computer. The June 2012 is a survey paper published on interview research. And also, there are software, actually software special issue. The software engineering for internet computing, interview and beyond is coming early 2015. If you are interested, you can check these two articles about our research. So, I will enter the third part. In the third part, my talk will briefly introduce how to support the engineering of interview. As I mentioned, interview system essentially is global software engineering. The engineering of interview is a typical kind of global software engineering. So based on my understanding, the so-called global software engineering faces following challenges, which are also the issue to be solved by the interview research. So first, how to organize the distributed and heterogeneous software assets. Software assets are distributed globally. Developers tend to compose the system by a set of distributed autonomous software asset entities. For example, web service, open API, and all. Meanwhile, open source software from Apache SourceForge become very popular in software development. Secondly, how to support the global development fashion like outsourcing or cloud sourcing to reduce labor cost. Outsourcing allows enterprise to partition a software project into several parts, in the different jobs, and developed from the other areas or countries collaborated to accomplish a task. Crowdsourcing further leverages the wisdom from cloud, or collective intelligence in the global area. Furthermore, there are also some other open challenging issues, which include how to achieve efficient communication, coordination, and collaboration. How to manage disputed and collaborative software development, and how to acclimate and manage the resource, the knowledge, and so on. Due to the time limit, I wouldn't talk all the technique addressing this challenge. In the following slides, that I mentioned this slide, I will focus on the internet engineering approach and the interview tools and the IDE. The two main tasks of interview development are the development of interview entity and the development of on-demand cooperation. We propose an approach and methodology, we call it ABC. It's architecture-based component composition. As a systematic engineering approach for developing and evolving interview setting. First of all, ABC introduces the software architecture into the whole life cycle, and then almost all activity in life cycle are performed under the guide of the software architecture. For example, the on-demand collaborations of interview entity are controlled by a one-time software architecture. That is, the development of on-demand collaboration is actually to develop the software architecture which control the interview entity in the long term. The ABC approach also provides a set of tools and mechanisms for architecture-centric development and evolution. We also used this approach in the 2008 Beijing Olympic Games for 8 information system modeling. ABC approach could support automatic domain modeling with feature model from the global distributed resource. So we can find many web service application, from the internet, and we can target as a knowledge and build the target cloud and the domain construction by target clustering based on the given key tasks that can be refined by changing the clustering parameters of manually. Now we can get a refined domain. And from this domain, the target as object service. If a similar actual service exists, similar matching from the given task, and get this picture. And also the domain with the candidate entity for travel is constructed automatically. Then from this picture, we can refine and customize with ABC future modeling tools. Now this is a future model. And this picture shows how to transform a feature model to a high-level software architecture automatically. So which is future model is the future and is a relationship. And we introduce responsibility as a lead level entity and from future map the future to responsibility, then responsibility to some component to implement this component actually is the implement of the different features of the service. So this picture how they find in the software architecture. After we get a high level software architecture, there is architecture design from the requirements, specification, and they get the early draft software architecture. Then we can use this loop, architecture level analysis for non-functional requirement, And after design for the non-functional requirement, the different loops, we can get a self-adaptive software architecture and use the runtime software architecture to guide the self-adaptation supported by the middleware platform. So it's we can get a dynamic and adaptive software architecture. And in this picture, we how incarnating the architecture into the runtime, how in the runtime. We use it in the smart approach enable the runtime architecture in Interview. Basically, this picture, this is a runtime setting. It's running setting. So we get a date just in and organize to both component models and feed is-to-be model to analysis and the decision tools, as in tools. Then effectuate the integrated analysis results of visualization, and the query transform and the synthesize sets and the changes. This is change data according to the to-be model and the feedback to the running system to adjust this performance and behavior. This is first part. The second part, how to support the collaborative development of Interview. So we constructed a trustworthy integrated environment, which is called the trust tier. So this picture shows the trust tier architecture, the organization. The trust tier is a platform that provides tools and the service from the collaborative development, crowdsourcing development, and the slide show. This is we started the trust tier community site. It is a website. And it also has a software component, software resource repository. And also have a development support the platform to support the collaborative development and use some development data and a set of tools and based on this infrastructure, we can build some domain-specific software production line, and for the software resource and the trustworthiness evaluation. Trust tier provides three types of services. The software trustworthiness evaluation services. The software collaborative development services, and the software resource sharing services. And each of these services are supported by several set of sub-services. For example, the project creation service and the project production service composed to the software collaborative development service. This picture shows how the trust tier supported the traditional software development by providing project communication, collaboration, management, and development. This is the project communication and the collaboration. The project management weekly and follow mainly instant message, and the project management and the development including the life cycle management, configuration management, behavior analysis, and maybe mirror Eclipse extension. It's some plugin tools to support this. This picture shows how trust tier supported the global collaborative development. In particular, developers use the collaborative development platform through the crowdsourcing development portal. Based on the software collaborative development platform, the developer can use various different tools provided by trust tier. At the same time, all resources collected during the software engineering development are taken as a shared data like just here, so that the developer of the same project or even the different project may use them to speed up the development to improve the software quality. Yeah, software quality. This picture shows the Chartier application model. So the left part shows the application models of Chartier on the traditional software development, where the right part shows how to support the code sourcing. So this is project maker can create a project, and the different maker can come together to develop in the same project. And this is a teacher or higher. We support also supporting the teaching course for software engineering. They can publish jobs or tasks, and the different makers or students can bid and bid the job and submit their work. This is a Chartier portal. This feature shows the portal of Chartier, which consists of a collaborative project for software development, research, and resource sharing, and so on. So on DLO, there are 20,000 registered users in this system, and the registered project is about 760. Enterprise users, there are 268. The daily access value is more than 15,000, and access from outside China now is 100,000 to 102,000. So besides the software collaborative development service, Chartier also supports the software resource sharing service. So this picture shows the architecture of Chartier software resource repository, which supports the software resource sharing among the different projects or development. In this Chartier software resource repository, the Internet software resource search engine aims to search various resources from Internet to facilitate the software development. The software resource Chartier evaluation aims to evaluate the resources published on this repository. Moreover, this library also provides software resource publishing, software resource classification, software resource training, and user management. The Chartier software resource library provides an external interface to support collaborative development as well as the traditional software development. So this slide shows the portal of Chartier, the Chartier Chartier software resource library and resource repository. In this repository, we support the software resource publishing, retrieval, classification, user management, and statistics. In this library, implement some internet-based software resource system, search engine, and the web service, queues management subsystem. However, it is supposed REST certification, REST certification for the resource store and the management. We also can manage the user feedback to support the user to publish and retrieve their feedback information. Now, in this library, we have been this is a number of software components, including the usable source code, jar, and also the service over the internet. All the services, the validation are checked, and the software tools, and some framework, software architecture implementation the framework, and the open source software project, and other different documents. Now, the trusted infrastructure in China, the trusted has been deployed in different parts of China. It's Shenyang, Beijing, Xi'an, Jinan, Shanghai, Changsha, Chengdu, and Guangzhou, different parts in the software park. Now, the final one. I will present some personal thoughts on cloud software. Today, the internet, we so-called the network of networks, has become not just a platform for choice for delivering service to increase mobile users, but also the connective tissue among people, information, machine, and all the physical things. The newest and almost popular computing and the application model has been born on the internet. All this motivated by the internet, especially the cloud computing on internet, mobile or social computing on mobile internet, the cyber physical computing on the internet of things, and also the big data on the top of the three computing model. So this is a new era. It brings many challenges to software technology and to global software engineering. One big trend of global software engineering is the big data in software development. During the whole software lifecycle, different stakeholders would use various tools, library, service, or platform, which in turn produce a large value of data. Due to wide application of internet-based software system, data keeps increasing in high speed. How to collect, organize, analyze, and use the big data to improve cloud software development is an interesting program. So we like all the lifecycle data from both enterprise or open source with powerful analytics. We can find some correlations and causation from the data. Further discover some valuable experience, practice, or even rules. All the knowledge should be accumulated little by little and guide further development activity. Hence, the big data would be a powerful weapon for improving software development efficiency and quality. For example, with the big data in the whole life cycle, we can discover the development knowledge through mining and analysis. The knowledge-based intelligent recommendation can make the software tools smarter, more and more automated. Currently, the global software engineering would suffer from unfair computation resource on distributed teams, diverse and heterogeneous tools and platforms in all the lifecycle phases, efficient communication and calculation, and so on. So, one possible solution is to provide a cloud-based online tooling for global software engineering. The development resource can be integrated and allocated on demand, so that the capability gap between distributed teams is fair. IDE and other tools are delivered as a cloud service. All the development activity are completely over the internet, which is marginally impacted by local resource. Also, cloud keeps centralized control of the development and to improve the communication and the collaboration. The third part is about the global software engineering become become more and more popular with this popularity. As we mentioned above, the big data and the cloud-based online tooling are improving our productivity and the quality. However, at the same time, security and privacy protection becomes a series of challenges. Develops personal information or enterprise confidential information are likely to leak during the globalization. How to protect the personal, organization, and enterprise data. In China, I will tell you about our future work. So I also focus on two parts. The interview research in China is still going ahead. So actually for the methodology for interview, we got the third 5-year license project. This project uploaded this year will begin formally next year. This is the third one. The third project. So they are focused on open source ecosystem-based interview engineering. It's a little focus shift. And also in this project, we'll do some research on long-term support, development support, and some fundamental issue, and also how to measure the quality, the productivity, and also the ADC approach is also a main point in this. This approach is still improved. The second part is for the trust platform. So now this project is going on. Will be ended by this project will end by the end of this year. That will finish by the end of this year. And also the third time project is on the plan. So for the future research, we want to get more software resources, the component, the different service of web service, and every kind of list for service. And this is resource library. And we also provide more online development service, different tool, cloud-based tooling. And also we want integration with the execution platform. And especially we built a long time for different, especially long time for the domain-specific applications in this platform. And we also built some data-driven intelligent recommendation for the software tools become smart. And more robust for security and privacy protection. And now we are building, actually it's the Chinese language open source community on this platform. So okay, that's it. Thank you.